We're going up next with measuring detection engineering teams with Kyle Bailey. This is going to be good because part of success in continuing to move forward with greater efficiency or learning from our mistakes is, well, making sure we have the measurements to try to understand what's going on. So, Kyle, if you're here and ready, I can turn this over to you and look forward to it.
Yeah, I'm ready to go. Looking forward to it. I think I have control here. Let's triple check that. Looks like I do. Cool. Alrighty, so should be a good segue here. It sounded like at the end of the conversation there, a lot of talk about visibility, logging, and detection. So the goal of my talk here in the next 40 minutes or so is going to be talking about measuring detection engineering teams. So sort of the primary scope of the talk is going to be breaking down a maturity matrix that I released a few months back, and kind of decomposing that and talking about kind of how you can measure your detection engineering team from like a strategic lens, and also we'll dive into a few metrics as well that you can start looking at collecting on your detection engineering team. I guess I should introduce myself as well. So my name's Kyle. I'm a security engineer currently working at Panther Labs, which is a cloud based detection platform startup. But yeah, let's jump right into it. So like I said, the core of the talk here today is going to be around some core principles that make up the maturity matrix that I built out for detection engineering teams. So I'm actually going to spend not a whole lot of time on the actual matrix itself. I will leave that for y'all to go check out and kind of digest, and feel free to contribute to it as well. But really going to spend most of the time talking about these core principles that kind of make up the content of the maturity matrix itself. So there will be a little conversation, or a little bit of a conversation around detection logic itself, but most of the core principles are sort of around building detection engineering as a program, a lot of the processes and tools that are important to have in place to build a successful team. So from there, that'll be the bulk of the presentation. From there, we'll go into a bit of motivation and methodology about why I built the matrix. We'll touch briefly on the matrix itself. I felt like I was doing a disservice if I didn't include a slide on metrics after calling my presentation measuring detection engineering teams. So we'll touch briefly on metrics. And then I have some resources at the end as well. And hopefully we'll have some time for questions at the end. Cool, so why the heck should you listen to me? So just kind of brief background about myself. I spent 5 years managing cyber operations teams for the Air Force, and a little bit for cybercom as well. From there, I decided I was ready to go get my hands dirty. So spent a few years working in incident response, running incidents, building teams, doing that kind of stuff. About the last 2.5 years, I've been at Box, helping build the detection engineering team from sort of a very ad hoc kind of function to a formalized program, and formalized sort of individual team that handles all of our detection work. And like I said earlier, currently at Panther Labs, after spending a couple years in management, I do a lot of breaking things right now. So still working on figuring out how to not break things. And then, so my wife and I have a bunch of animals. This is our female cat who made the slideshow today based on the fact that about 2 minutes after this, she decided to like chew through my Mac power cord. So she's very good at finding the most expensive cord in the house to just chew through. So she gets the honorary mention for this slide deck today. Alrighty, so jumping right into the core concepts. So these are, like I said, overarching areas that make up the content of the maturity matrix itself. So these were 3 major areas that, in my time at Box and building the detection engineering team, we found that focusing on each of these areas, every quarter or every, whatever your planning cycle was, really helped us kind of move our team in the right direction. So I'll dive into a little bit of each of these here, and then we'll do deep dives on all three of them. But just kind of at a high level. So I did try to order the core concepts and the actual like components of the core concepts themselves, and sort of hopefully in order of like ease of implementation. So starting with things that are process changes that could be implemented without needing to go buy or build technology, to kind of help the team kind of start moving in a direction to shift yourself to the right on the maturity matrix. So the whole slide deck is kind of ordered this way to hopefully help make it a little bit easier to decide, like if you're looking at all of this and it can be pretty overwhelming, kind of like where's the best place to start. So one of the, just kind of starting at the top here, one of the areas that we really focused on was what we call the incident response experience. So how well are we doing at providing our incident response team actionable, sort of high fidelity alerts that contain enough context for them to go take that alert and do something useful with it. I guess one thing I want to sort of step out of here real quick is when I talk about the incident response team, this can look a lot of different ways. There's a lot of different sort of team structures and org structures. The incident responders, when I talk about that as either being a team or individuals, it's the people responding to the alerts themselves. It may also be the people who wrote the detection. It may be an individual team who only does response, or maybe a combined team. I don't want to get into sort of all of those org structure conversations here, but sort of generally focused on, whoever's doing the responding to the alert, do they have what they need to do their job? The next one we'll talk about is detection logic and the infrastructure itself. So a lot here about log visibility, some about logic, but that's obviously a much more technical conversation that could go on for days or weeks or months or probably forever. And then some around, I guess, what I call like process infrastructure almost. So things like purple team exercises, like how is your team implementing MITRE ATT&CK, those pieces to help sort of direct the team to ensure that you're working on the right things and the things that you're working on are functioning as you intend. And then last is a cool concept that I've really come to love over the last couple years, is what's been coined as detection as code. So detection as code is basically the concept of treating your detection logic as code. So following software engineering principles, running your teams in an agile methodology, using things like version control, CI/CD pipelines, testing, all of those components that have made software engineering teams so successful, and really trying to take those and bring them into detection engineering teams and running the team as the same way a software engineering team would. So just a high level there. We'll start jumping into each of these individually. All right, so we'll start with the incident response experience. So the main question that we're trying to ask ourselves here is, like, do the alerts set the incident response team up for success? So one of the places where we started when I started building the team was documentation and context for the responders. One of the things that can be really challenging is an alert being built and not having context around why it was built, how it works, if there's any known blind spots or known false positives. All of these components can be really helpful for incident response and also another detection engineer down the road to look at this detection and say, why was this built? How was this built? How does it work? And having that documentation and context is extremely important for both of those teams to be able to understand. Maybe if you're looking at improving an alert, how can we improve it? Or even if I'm responding to the alert, how does this work? What exactly would it have triggered on? Does this make sense? Does this look like a true positive? And can really help the incident response team kind of like boil down those sort of like thought processes and conversations. So a great place to start, and where I started was the Palantir alerting and detection strategies. This has been out in the wild for a while, and it is a great sort of set of sort of high level pieces to document when you're building a detection use case. We took this and tweaked it to our organization. I think I would encourage you to do the same. I think there are some components that may not make sense depending on how your team runs, or sort of like how your team functions and what your processes are internally. But would definitely encourage you to look at that and start there. It's just sort of a template for how you want to document your detection. So the next component is alert fidelity, which is obviously a huge topic of conversation, but also being able to monitor that, monitor your alert sort of catalog from a fidelity standpoint, and also being able to have the right resources to maintain those alerts as they age. So, obviously, we're all doing our best to go build and release, high fidelity alerts as we're creating them. But are we doing a good job of, watching that alert 6 months down the road to make sure that, something in the environment didn't change, something in logging didn't change, or something, in like how a piece of software runs didn't change, that's now all of a sudden sort of triggering this alert. Maybe our engineers have a new workflow that's all of a sudden triggering some cloud monitoring that we didn't have, wasn't occurring when we released the alert. So being able to track these, track fidelity and monitor that, and even potentially surface those low fidelity alerts in an automated way, can be really valuable to the detection team and to the response team, to be able to keep an eye on things that were built, and making sure that you're constantly sort of providing a high fidelity experience to your incident response team. So segueing into that a bit is kind of what I coined the detection and response relationship. So I think, it can be challenging, especially if the detection team is not releasing high fidelity alerts, if they are low value, if the incident response team doesn't understand why they're getting the alerts, why they're responding to them. That can create friction in that relationship, and that can cause a lot of rifts between those two teams. So one of the things that I think is important to do is, especially as you're building new alerts. So we just talked about sort of monitoring existing alerts, but as you're building new alerts, thinking about the incident response team first, kind of like you're starting with them in mind. Is this something that is worth their time to go investigate? And then maybe even defaulting to, can this be automated in some way? Can the response be automated? Or can the alert be sent to an end user instead of being sent to a SOC analyst or incident response analyst? And then one of the last questions too is, are there tangible response actions for them to take? So seeing maybe web scanning could be valuable, but depending on, we know web scanning occurs all the time, and then may or may not be something that you're actively going and blocking or making changes to for just generalized, internet scanning. Does the incident response team necessarily need to know about that or have a human look at it? So I think that those are good questions to start asking yourselves, especially as you look at maybe high volume alerts that you've or alerts that are creating high volume to your incident response team, or as you're building new alerts. Of course, asking yourself and the team asking themselves these questions. And then the final piece here on the incident response side is does your detection team have a way to kind of automate that resolution? So do I have a way, maybe via a Slack bot or a Teams like bot, to go validate with the end user, hey, was this you, yes or no? And I think that can be a great way to take a big chunk of your alerting that you still want to validate, and free up a lot of sort of manual tasks that your incident response team may need to take, where they're just doing something that a Slack bot could. That's frustrating, and if your detection team has a tool like that to be able to send alerts to, you can validate the action, free up your incident response team to do like meaningful analysis. So I think that that's a great tool for any new or incident response team and detection team who's looking to kind of take their sort of detection and response sort of combined process to the next level. Using Slack bots and chat bots is a great way to kind of do that. Alrighty, moving over to detection logic and infrastructure. So the high level question we're trying to answer here is, how good is our threat visibility and then our ability to detect those threats? So log visibility is obviously something that is probably number one here. And then timeliness, another important piece. So a lot of conversation on this, of course, but can you, if a malicious activity occurs, can you see it in the data? Do you have the logs from the operating system level? Do you have logs from Active Directory? Do your audit policies collect the event codes that you need? Does your cloud management plane, are you getting all of your admin audit events? Are you getting audit events from the cloud services and then the applications that run in those cloud services? So a lot of pieces, obviously, to visibility, and it's with challenges with SIMs, it's necessary to kind of pick and choose, right? But making sure that your team is doing what they can to make sure that they have the visibility, because it's obviously really hard to do anything else without that. Another important question to ask, and this gets kind of overlooked oftentimes, especially in the cloud world, is how is the data reaching me in near real time? So depending on how you're pulling logs out of things like AWS or GCP, even from your EDR, you may not be getting the logs as timely or in as near real time as you think you are. So it's very, very much a good use of time to go validate that in your sort of environment and how you have your log pipelines architected to make sure that either the service is adding some delay. Being able to monitor those delays and make sure that they're not occurring, especially for cloud services, is extremely important. And then the last piece that I don't think gets asked enough is, are we removing unnecessary data from the SIM? So it's easy to look at the first bullet and say, like, yes, all of these log sources have meaning to us. We need them for X, Y, and Z scenario that we can sort of like draw up in our heads. But is there unnecessary data there that's potentially bogging down your SIM, that's taxing your license, that's preventing you from putting data in that you actually need? So I think that being able to sort of review and take time to look at the data that you're ingesting in your SIM and sort of ask those questions can be really valuable in terms of freeing up your technology to work for you in the right way. So the next piece I'll talk about, feel obligated to talk about MITRE ATT&CK, of course. I'm not going to go into depth here because there's an entire conference dedicated to that. But I think this can be really organizationally dependent on how you implement MITRE ATT&CK. What is the right way for your organization to do it? It took us, quite a while to figure out what the right way is for us to use MITRE ATT&CK in our environment, in our processes. I would encourage you, if you're not doing it at all, to figure out like what's the simplest way that we can do it. What's the lowest lift process or sort of workflow that we can use to start, including MITRE ATT&CK in our documentation is kind of actually the first place we started adding MITRE ATT&CK information, and then just building from there and kind of just continuing to iterate on how you integrate MITRE ATT&CK into your detection workflow. Because it is such a useful tool for tracking your detection, making sure that you have the coverage that you need, and especially when we go into the next slide talking about threat actors and really being able to communicate to your leadership and the rest of the community to say, here's we're comfortable that we have detection on this TTP. Being able to use MITRE ATT&CK is obviously the gold standard to doing that. So the next couple pieces here, purple teaming. So this was something that we started, actually sort of down the line here. And this 1 hour purple teaming presentation by Ben Gurs, I'm probably butchering his last name, sorry. I think is a great place to start. So this is exactly how we started. If you're not doing purple teaming, it can be a bit daunting when you say like, oh, I need an offensive engineer, I need like a red team to go do this, and you don't necessarily. There are a ton of resources out there. Ben lists a ton of good ones. Atomic Red Team, of course, from Red Canary is another good one that I think I hope I have listed on the final slide here. But being able to use those tools, validate the detection your team built is actually working as intended. One of the most frustrating things can be building detection, taking the time to do all of the work, build all of the logic, and then realize that it's not functioning. And that can be a sort of like kind of deflation event for the team. So being able to run through those either as you're building it or running through it after the fact and sort of whatever the right process is for your organization, your team, can be really beneficial. And then finally, threat intelligence. So obviously direction for the detection team is extremely important. And this is where threat intelligence comes in. So being able to really focus on things that are probable, not not what's possible, right? So looking at the MITRE attack matrix, it's giant. And it can be overwhelming to try to score how well you detect everything on that matrix across all of your environments and operating systems. And it's basically, not possible in my opinion. So really kind of trying to focus and actually in the purple teaming video, there are ways to sort of like take this first step if you don't have a formalized threat intelligence team. Looking at things like PowerShell, running, like starting there and working your way down sort of that ladder of what is most probable down to what do we feel like is, maybe rare or maybe something that an attacker is going to use in the point in the 1% of attacks, and being able to just start with those big chunks and focus the team and give them direction is really valuable so that they're not, sort of spinning wheels and wondering like, what are we supposed to be working on, finding things in blog articles and new threats. That's all great. But are you doing the basics and using, sort of this like what is probable, not possible methodology, I think is really valuable. All right, detection as code. This is the fun part. So are we using engineering processes and principles? So again, ordering this in sort of like what I perceive as level of sort of difficulty to implement this may be different for your organization. But one of the first places that I started and that my team started in was moving from just sort of a completely ad hoc workflow, just sort of like building detection and not really, maybe tracking it in tickets or like Jira, but not necessarily using a formalized Scrum or Kanban model, not using a board, not running sprints, whatever we were trying to do, we were just kind of very ad hoc. And I think that formalizing into a process where we were running either whether you're running sprints or running just a Kanban workflow, having a prioritized backlog, and then sort of enforcing these workflows in Jira or in wherever your ticketing platform is, really helps cement that each of these sort of steps process are happening as you're building detection. So are you like this workflow, and the link is there from Alex is a great workflow and one that we modeled. Really enforces the team to sort of follow these steps. Are we prototyping? Are we thinking about the incident response team? Are we asking those questions that we talked about earlier? Are we testing? Are we developing? Are we handing things off to the incident response team so they understand how this new detection logic works? Are things being documented? All of those sort of processes cemented in a Jira workflow make them sort of ingrained and make sure that everything's sort of all the processes are being followed as you would expect. So the next piece is code reuse. So this is talking about, when we think of this in software engineering, we think of, taking pieces of code that, do the same function or, work the same way and breaking it into functions or, definitions, whatever your programming language is. And sort of following this mindset in detection logic can be really beneficial because say you need to make an update, right, to that piece of shared logic, you're only doing it in a single place. You're not necessarily having to go to every alert where this is used and make that change. And so this can be difficult depending on the sim that you're using. Your sort of like query language may not, your sim may not have that functionality, but thinking about how you can sort of fit that mindset into your sim's query language, and always sort of thinking about like how can we sort of reuse functions or reuse processes, can be valuable even if it's not true code reuse as we would sort of define in the software engineering world. All right, and so the last few pieces here. So version control, I think that this is one of the sort of like, probably, I don't want to coin anything here most important, but version control really unlocks these other two components. So being able to have your detection logic and your source of truth for your detection logic in a place like Bitbucket or Git can be really powerful. And there's a lot of sort of functions that come with how of those tools work that are really effective for the detection engineering team. So just some examples, like as people are making changes, you can see exactly what was changed, right? You get a very nice like diff between old logic and new logic. You can enforce the peer reviews in your version control system. You can enable the CI/CD integration piece that we'll talk about here in a second. You can perform rollbacks. All of these like benefits that you obviously have the entire version of your detection catalog in a single place, and then doing things like making mass changes across all of your alerts can be done really efficiently if you need to do that for whatever reason. So I think striving towards how can we get all of our detection logic and version control is a great place to sort of a North Star from a detection as code sort of lens. And a lot of sims these days are either integrating it directly into the product or may have some pre-built code that helps you sort of do this on the side. So I'd encourage you to check with your sim provider. They may have something like that to help you sort of get your version control or get your detection logic out of your sim and into version control as your source of truth. And it really helps with some of these other components that we'll talk about here as well. So CI/CD is the next piece here. So as your team is say peer reviewing and merging changes in version control, you can leverage a CI/CD pipeline to automatically push those changes into sort of a production alert in your sim, right? So those sort of like push changes happen automatically. You're not relying on anybody to say like copy logic over, or maybe you didn't hit save or some of those things that whatever the case may be, that your production logic is now different. And the CI/CD pipeline can enforce those things. Another great thing that we just started to dip our toe into at Box, which I think is really powerful, is that you can enforce testing. So you can do things like linting checks in your across your detection logic as it's being pushed into version control. You can look for things like, do I have, maybe someone's using wildcards when they shouldn't be? Do I have all of the like, why am I blanking on this? Do I have all of the like metadata fields that I need or that I expect my incident response team expects from a metadata standpoint? there are a lot of benefits, and you can think of things in your org as you have, so many times we deployed detection logic that had errors in it, and being able to go write those checks in to this linting pipeline is extremely powerful way to prevent those things from happening and prevent your team from deploying errored detection logic. And so someone in your org, especially if your org builds software, someone's already probably using Jenkins or Circle CI or some other CI/CD framework. Go get their help, because they would, I'm sure, would love to help you, and they will help sort of like help you glue these pieces together. That's what we did at Box. Like, I didn't have any experience, my team didn't have experience on how to sort of glue all of this together. We had the team help us sort of get to reach our goals. So I wouldn't expect, detection engineers to know how Jenkins works, but someone in your org probably does, and would probably be very willing to help you. So the last piece is static and dynamic testing. So talking about this a little bit above, but making sure that you don't have errors existing. And then maybe even like, does my logic catch this malicious activity? So one of the things that I always theorized was like, we could dynamically run the logic as we were running it through the CI/CD pipeline to validate that it either returned results or maybe it wasn't returning too many results. And running dynamic tests like that, I think is not something that I've seen done, but something that I think is very possible in a CI/CD pipeline. It'd be really cool to go check those things to make sure that dynamically the logic is also functioning as you're running these tests. And again, there, as I mentioned, Atomic Red Team. So Atomic Red Team can be a great place to help you with purple teaming. Purple teaming is another way to sort of manually do dynamic testing. So this doesn't all have to be automated, of course. That doesn't need to be your first step. Being able to understand how you do these things manually, running atomic tests, making sure that your detection logic is firing, just doing those things manually is a great place to start, with sort of like building those pieces and looking at, okay, how can we automate them down the road, and sort of planning and building to those things. So that's detection as code. Would love to do like an hour on detection as code, because I think it's really cool. So, all right, jumping a bit into the matrix here. So talking a little bit about kind of why I built it. We had been sort of building these pieces, and I've been seeing a lot of other articles and conversations in the community about sort of detection engineering, detection as code, a lot of these pieces that other teams were doing. And I wanted to sort of capture that in a hopefully simple and consumable format. I couldn't find that a detection engineering maturity matrix was built, and I wanted to kind of like get us on a roadmap and be able to show, my CISO where we were headed. And so it felt like a reasonable thing to go build. I was also building a red team maturity matrix at the same time, and red teams .fyi like really caught my eye. I liked how simple it was, so I definitely modeled it off of red teams .fyi. And I think another important piece here, something that you'll see in the matrix itself, especially as you get farther right on the matrix, is that your detection engineering team is so highly dependent on other teams to be successful. We talked about threat intel giving your team that direction, incident response helping give you that feedback of like, these alerts are crap, help like fix them for us. Having those feedback loops, having either a red team or a way to go test your detection from an offensive standpoint, and then also having buy-in from your engineering team. Maybe they're building you logs for your custom applications. Maybe they're running your SIM. Maybe they're deploying things into the cloud, and you need them to do that in a secure way so that you can effectively detect bad things. So having all of those teams sort of working in concert, which obviously is a much bigger conversation than this talk here, but just wanted to sort of like iterate or reiterate the importance of that. Okay, so the matrix is laid out in this way, and I have it on GitHub, so feel free, it's there. I would love pull requests to it to improve it, or like tell me that this makes no sense, and let's change it. I would love to sort of collaborate on it with the community. So I have on the left here broken down into 4 rows: people, process, technology, and then I also added detection. So people, of course, talking about the team owning, creating, and maintaining the detection logic and infrastructure. And then also kind of leadership awareness and buy-in for properly resourcing this detection function. I think there it's growing, but the realization and how the importance of a really well-run and solid detection function inside of a security team is so important to be able to do that well, to just have overall success of the security team. Process. So the process used to prioritize new detection, track your work using agile workflows like we talked about, monitoring that existing detection fidelity, tracking metrics, working with the incident response team. Finally, or sorry, not finally, but technologies focusing on the SIM and surrounding components that give your team the log visibility. So we've talked a lot about SIM or about the SIM, but that may also be things like bro scripts that run on your maybe like security onion servers, Suricata rules, maybe logic that lives in your EDR. There's a lot of other places where detection logic lives. So I have focused a lot on the SIM today. But keep in mind that those other pieces are there too, and they would, in theory, fall under this sort of detection as code principle. YARA rules would be another good example of that, wherever you're doing sort of, YARA analysis. And then how well are you doing detection as code? How well are you sort of enabling your team to follow those principles and sort of follow those processes? And then finally, the detection section talks about both the robustness and fidelity of your detection logic. What's driving your team to build new use cases? Are you doing things like using threat intel to kind of drive and focus direction for the team? Things like purple team exercises and testing to validate that your logic is working now and continually working. And then some minor attack integration pieces there as well. So again, it's on GitHub. I'll actually share this link in the Slack channel as well after this. All right. Like I said, I felt like I'd be doing a disservice of not actually talking about metrics, so I'll kind of cruise through these. So hopefully we get some time to talk questions here. But so I have this broken down into two categories. The same kind of workflow here. So like the metrics at the top should be, in theory, more or easier to implement, and they get more complicated as you go farther down, or you need more pieces in place to actually go measure these things. So things like false positives, or maybe even like how often are we alerting on things that are expected, or things that we maybe want to know about, but we expect to be happening in our environment. Those can be taxing to the incident response team. False positives, of course. So watching both of those metrics, I think, is important. The percentage of alerts resolved by an end user. So talking about, if we're using a Slack bot, how good a job are we of actually leveraging the bot as opposed to sending things to an analyst. So there's probably a better way to measure that, to be honest, but that's one that we looked at to kind of gauge how well we were sort of splitting the work there between automated workflows and manual workflows. Mean time to detect, obviously a big one. So whether that's an actual sort of like breach scenario, or even you can pull mean time to detect metrics out of your purple team exercises is a good place to do that as well. So mean time to detect is a good one. And then so these get a little bit more complicated. So talking about after you've defined your sort of probable attack TTPs that you think a threat actor might leverage in your environment, how well are we doing at covering those? And you need purple team exercises to maybe test those TTPs to get an idea of how well is our detection logic working, how well is our EDR working, those kinds of questions. Probably should have flipped these two, but this one also, detection. So the percent of your catalog tested by a purple team exercise. So you could also, instead of focusing purple team exercises on attack TTPs, that's one way to do it. You could also just go out and test individual detection logic as well that you built. So there's kind of like two theories of thought there. Finally, some detection as code metrics. So how much of my detection logic is in version control? what percent of logic do I have maybe tests associated with, or some test coverage there to validate that, I'm not pushing errors into, excuse me, into production. And then maybe percent of like deployments where we push out that actually have errors, and maybe we need to go write tests for those. So just some ideas there. Hopefully that's helpful. A couple of those may be useful, and maybe even spur some thought, other things that would be useful to your organization. Listed a couple of resources here. So a Palantir alerting and detection strategy, I think is a great place to start. Like I said, this is the link also to the Jira workflows for detection engineering teams, which is great. Some conversations on detection as code. The Google Cloud Security podcast has done some good conversations on detection engineering, and a lot of sort of like theoretical thought about what makes the detection engineering team, run most effectively. So they have a couple episodes there that are good, or really thought-provoking on detection engineering. And then I have another article around testing that I like. I'm really into testing, so if you're into that, that's there as well. That's actually all I have. So I think I hit the time, what I was trying to do. So I don't know if we can answer some questions.
Yeah, no, you had a lot of information in there. So does anybody have any questions? I mean, I from looking at your maturity matrix, it looks pretty clean and concise based on very similar to the red team maturity module you're reflecting. And I gotta admit, your talk was one of those ones that I read the description and you covered exactly what's in your description, but my mind went completely different. So yeah, no, this was great. Have you found like as you started working with the teams, getting up like even like the change pipelines and putting it in and trying to get all that integrations, what did that look like? Like, was there pushback on the time commitment to set that up, or did people clearly understand, yeah, this is going to help?
Yeah, there was definitely a little bit of back and forth to kind of help understand why we needed this. So there was some back and forth, but I think we to be honest, like really lucky at Box, we had a couple of dedicated individuals that could help us do this. And but they obviously had other priorities, so like there was still a little bit of back and forth to try to help kind of have them understand the importance, and it actually did help some of their workflows as well. So there were benefits to both sides. So I think being able to sort of find those like shared benefits and sort of like common ground areas made it a little bit easier for us to help get those projects going. But it did take a couple quarters of kind of back and forth of planning and figuring out the right workflow to actually get them implemented.
Sure. Did you find, like, looking back in retrospect, would there have been a different way you would have pitched it to try to get it approved? Because I find that like I learn a lot from like that uphill battle, and now that I'm at the top, it's like, wow, maybe if I would have used this verbiage or said, I notice at the end of the project, like our detection techniques, like you're talking about, like automatically validating them with maybe purple team or linting tools, and some of that I'm sure you come up with as you were building this out. So like, if you were to give advice to everybody listening on like what's the value to the detection engineering team or to leadership, like what's the elevator pitch?
Yeah, that's definitely not my specialty.
Oh, come on, Kyle.
Quote my own boss on that. But I would say, yeah, it's really about I don't want to say time saved, but like the ability to do your job effectively. You're not right. You're not going back and forth, pushing errored logic, pushing bugs. You're able to, like, especially when you look at making changes, the team is able to like quickly figure out what changed between each version, and you know, it makes that review process a lot easier. So it's almost like it really like up levels the efficiency of your detection team, and helps sort of, I guess, like prevent errors, help them operate more efficiently. I'm not sure that's a great elevator pitch, but
Yeah, no, it's all good.
but yeah.
And then there's a few questions in via Zoom. And I'm not sure if any of these are ones we've got 1 minute left. Otherwise, we can kind of move these to Slack. But does this apply to an MSSP environment? I'm going to lean
I would,
towards yes, but
yeah, I would say if really any environment that's managing detection logic, I would say yes. So for the MSSP itself, if you're using an MSSP as an organization, I would maybe, it depends on how you interact with them. I think, are you giving them logic to use? Maybe a little bit more is needed, but if you're an actual MSSP, I would think, you know, I would think there are a lot of benefits that can be pulled there.
no, absolutely. Well, and time is money with an MSSP. So the more mistakes you're making and have to roll back, the more you're wasting labor and other time. So, well, Kyle, this is fantastic. Very much so appreciate it. And then if there's anybody have more questions, please put them in the hallway and we'll move from there. And thanks again, Kyle. We've got 5 minutes before our next talk. So here in a second, we'll switch to some purple team concepts.
Thanks, everybody.